What are interior and limit points? Let's look at an example to understand. Let's make this example the interval of the real line from 1 to 3, and let's have this interval closed at 1 and open at 3. Here's what that looks like. The technical definitions are as follows. X is an interior point of A if there exists an epsilon greater than 0, such that the open interval from x minus epsilon to x plus epsilon, also known as the epsilon ball around x, is entirely contained within the set A. And for limit points, Y is a limit point of A if for every epsilon greater than 0, there exists a P not equal to Y, such that P is in the intersection between the epsilon ball around Y and the set A. A reasonable question at this point is, what? And that's a good question. So let's plot a point to C. Here's a point X. The shaded region around it is its epsilon ball, currently with epsilon equal to 1/2. Epsilon is greater than 0, and this epsilon ball is entirely contained within A, so we would say that X is an interior point of A. But what about a different X? Say X equals 1.2. Well, with epsilon equal to 0.1, this epsilon ball is entirely contained within A, so 1.2 is an interior point as well. We can keep going with this, bringing X infinitely close to 1, and so long as X is just barely greater than 1, it is an interior point. We can find an epsilon so that the epsilon ball around X is completely contained within A. But what about X equals 1? Well, at this endpoint, we can see that part of our epsilon ball will always be outside of A, no matter how small of an epsilon we pick. So, since no epsilon exists to meet the criteria, 1 is not an interior point. This may be strange. 1 is inside of A, but not an interior point. That will take some getting used to. We focused a lot on this lesser endpoint, so let's zoom out to see what else is going on. Turns out it's a lot of the same around 3. So long as X is less than 3, we can find an epsilon small enough to keep our epsilon ball around X entirely within A. But as soon as we get to 3, part of our ball will always be outside of A, meaning 3 is also not an interior point. This should make a little more sense, since 3 is not actually a point inside of A. Remember, since the interval is open at 3, that means that every point up to 3 is part of A, but not 3 itself. Alright, let's rewind and take a look at this example for limit points this time. So, as we can see here, part of our interval is inside of A, and that part contains points that aren't our point X. Therefore, this is a limit point. You should be able to convince yourself that this is true for every epsilon. If we pick an X closer to our boundary, you can still see that this is true. The right side of that interval has points that aren't X that are in A. You should also be able to convince yourself that this is true for every epsilon. Let's zoom in, and we'll see that even if we move our point all the way up until the very edge of our interval, we still have points that aren't X inside of A. So this is also a limit point. But as soon as we move X outside of our interval, we will be able to pick an epsilon where this no longer holds. Therefore, any point at all less than 1 is not a limit point. This is simply because there exists at least one epsilon where the definition doesn't hold. You might be able to pick out that this is going to hold for the right side of our interval as well. Any point inside of A is going to be a limit point because it will have a point not equal to X that is inside of A and inside of our epsilon ball. However, interestingly enough, 3 is a limit point of A despite not being inside of A. Think about it this way. 3 minus epsilon will be an A because epsilon must be greater than 0. So our point P can be half the distance between 3 and 3 minus epsilon, or 3 minus 1/2 epsilon. This is in our epsilon ball and in A, so 3 is a limit point. But, just like with 1, any number even marginally larger than 3 will be too far away because we can find an epsilon where our epsilon ball is completely outside of A. This concept will take some time to grasp, so let's go over some important facts that you may have picked up on. Firstly, it turns out that every interior point is actually a limit point as well. However, not every limit point will be an interior point. You'll have some more time to grasp this, but for now, here's a good chart to help out with understanding when a point will be an interior point and a limit point for any of these given sets.